Hey everyone, welcome back to another Kubernetes tutorial. Today we are diving into the heart of Kubernetes, that is Kubernetes object. If you are a system administrator or a developer trying to get a solid understanding of what really happens inside a Kubernetes cluster, this video is for you. Let's break down the most important Kubernetes object one by one. Before we get into individual object, let's take a quick look at this visual overview to understand the big picture. Kubernetes object defines the desired state of your application and cluster, including which app should run, the resource they use, and how they should behave. They represent everything such as running a containers, storage volumes, networking rules, and configuration, all defined as an object. Kubernetes consistently monitors and adjusts your cluster to match the state defined by these objects. On the right hand side, you will see a simplified Kubernetes object structure. A Kubernetes cluster contains objects like pod, service, deployment, ConfigMap, secrets, and volumes. These objects work together to make sure your system runs the way you want, what Kubernetes calls the desired state. Understanding these core objects is essential for effective cluster management and application deployment. It's how the Kubernetes knows what to run and how to run it. Next is pod, the basic building block. A pod is the smallest and most basic unit in Kubernetes. Think of it like a wrapper around one or more containers that run together on the same node. For example, you want to run an Nginx web server. Kubernetes won't run the container directly. It wraps it inside a pod. One pod equals to one or more containers plus a shared storage or a network plus configurations. Next is service. Stable access to the pod. Pod can die or restart anytime, which means their IP address can change. A service gives you a stable IP and DNS name to access your pod. For example, your front-end app needs to talk to a backend service. You don't want to track every backend pod's IP, just expose the backend pods through a service. Service is equals to load balancer plus DNS for your pods. Next is deployment. Manage pod lifecycle. A deployment helps you to manage stateless application. It takes care of rolling updates, scaling, and rollbacks, all automatically. For example, you want to deploy a Node.js application with 3 replicas and gradually update to a new version. Use a deployment. Think of a deployment as a smart manager for your pods. Next is ReplicaSet, which ensures the pod availability. ReplicaSet maintain a set number of identical pods. If one goes down, it brings another up. Deployment use replica sets under the hood. For example, you want exactly 5 instances of your application running all the time. Replica sets ensures that happens. You usually won't create a replica sets directly, just use deployments. Next is job. Run a task to completion. A job runs your container to completion, perfect for batch jobs or tasks that need to finish and exit. For example, you want to run a database migration script once during a deployment, use a job. Once it completes successfully, the job is done. Next is cron job. Like a Linux cron, a cron job runs tasks on a schedule daily, hourly, weekly, and etc. For example, send a report every day at midnight, use a cron job. This is great for backup, cleanup scripts, etc. Next is config maps and secrets. Config maps lets you store a non-sensitive configuration. Secret stores the sensitive data like password, API keys, tokens. For example, you have a config file or a database password you don't want hard-coded into your image. Use config maps and secrets. Both can be injected into pods as environment variable or a files. Next is persistent volume and persistent volume claim. By default, data inside a pod is not persistent. If a pod dies, its data is lost. To fix this, we use persistent volume. that is PV, like a physical disk in a cluster. Persistent volume claim PVC, a request for that disk. For example, your MySQL pod needs a persistent disk. It uses a PVC to get the storage from PV. This helps keep your data safe even if the pod crash or restart. Next is namespace. Namespaces help you organize a resource into a virtual cluster, useful for a dev stage or a production environment or multi-team setup. For example, you don't want a dev and a prod apps to clash. Use separate namespaces. Think of them like a folder or a workspace in your cluster. Next is DaemonSet, one pod per node. A DaemonSet ensures that a specific pod runs on every node in your cluster. For example, you want to run a log collector like FluentD or a FileBeat on every node, then use a DaemonSet. Automatically runs when a new node joins the cluster. Next, StatefulSet for a stateful applications. Unlike deployments, stateful sets are for application that needs a stable identity like a database. For example, running a MongoDB or Cassandra cluster where each instance need a fixed hostname or a storage. Use stateful sets. It maintains the order, stable IP, and persistent volumes. Next is replication controller. Replication controller is the older version of ReplicaSet. It still works, but it's not used much today. Use ReplicaSet or a deployment instead. Replica controller is mostly for the backward compatibility. Now let's recap. Pod runs the container, service exposes the pod, deployment manages application lifecycle, ReplicaSet keeps pod alive, jobs or CronJob runs the task once or on schedule. ConfigMap or secret stores config data. PV or PVC persistent storage. Namespaces cluster organization. DaemonSet one pod per node. StatefulSet for stateful applications. Replication controller. This is an older version of ReplicaSet, still supported but not recommended. If this breakdown helped clarify the Kubernetes object for you, be sure to hit the like button, subscribe for more practical DevOps and Kubernetes tutorial. Thanks for watching. I will see you in the next one.